Okay, so use the directed line segment, segment AB, to answer the question, what are the coordinates of the point that partitions segment AB according to the part-to-part ratio 2 to 3? Enter your answer as an ordered pair with parentheses and a comma like this, parentheses 42, comma 53. All right, so directed line segments start, have an initial start point and have an initial ending point. So they start at the first point that they are listed, so A to B, that's why that arrow is there. So when we do our work, we are going to use point A as our starting point when we are counting for the part-to-part ratio. So on this, the first thing that I want to do is, one, find the total horizontal distance, and find the total vertical distance between the 2 points. So the first one is our horizontal distance. If we were to count from A to B horizontally, it'd be 1, 2, 3, 4, 5. So it'd be 5 units. The vertical distance is 1, 2, 3, 4, 5 units as well. So 5 units. So now the next thing is convert the part-to-part ratio to part to whole. So how do we do that? Well, we have 2 to 3 part to part. So that means that when we section this segment off, they want 2 parts up here at the point and then 3 parts below that point. So that's a part to part ratio of 2 to 3. 2 units from our starting point on our directed line segment and then 3 units below that point, so it partitions our segment. So now how do we convert that to part to whole? Well, how many total parts are there going to be? So the whole is the total amount of parts. So there's 2 here and there's 3 there, so we have a total of 5. So when we convert this to a part to whole, since we are starting it as a directed line segment from A, we know there's 2 units from A. So that first part comes over. So we have 2 units from A compared to 5 total units in this whole line segment that they want us to cut up. So now that we have a part to whole, we can convert this ratio to a fraction, or so we can find a percentage of how far down these we're supposed to go. So then we are going to convert to a fraction, which is 2/5. It's just how we would convert our ratio. And then now we're going to come back to our horizontal distance. So if we had this segment cut up into 5 equal pieces, that's the part to whole. So it wants 5 equal pieces, the segment cut up into 5 equal pieces. It wants the point to be located 2 pieces down. So when we do this, since this is counting and I have the total horizontal distance and the total vertical distance, I know I need to take 2/5 of that distance in order to find this point that'll cut it in that ratio. So I'm going to find the partition horizontal distance. Horizontal distance. So we would do that by doing 2/5 times 5, and that does reduce down to 2. And then we would find the partition vertical distance by taking our part to whole fraction, which is 2/5 times 5, because that's our vertical distance, and that equals 2. So we're now going to go over 2 units from A, because that's our horizontal distance, 2 units, and down 2 units so we can end on this line. So that's how I know to go down and not up. So we're going down 2 units, and here is where that intersects. So the coordinates of this would be -3, 6. So count these distances away from point A, since it's a directed line segment, and then the coordinates are -3, 6. So I hope that helps.